go over number 3 in the part 2 of homework 1.5. This was one where there was a little bit of confusion on part of this problem. So first of all, the temperature change, T, in Fahrenheit degrees in a patient that is generated by a dose Q in milliliters of a drug is given by the function T equals F of Q. So I think there's some confusion about what the input and output variables really are. So this is somewhat critical to notice that it's not temperature, but temperature change. And so I always like to draw axes so I can understand the setting of the problem. I know my input variable is Q. That's the dose in milliliters of a drug that's given to the patient. And the output is not temperature, but temperature change. So when you give a drug to a patient, how is this changing their temperature? And for example, when you give 50 milliliters, their temperature will rise by 0.75 degrees Fahrenheit. Most of you got this part correct, that F of 50 equals 0.75 means when a dose of 50 milliliters of a drug is given, the temperature change in a patient is 0.75. So their temperature, if they were at 98, they're now going to be at 98.75. This is the temperature change after that 50 milliliters is given. And then they describe something called sensitivity, which is the derivative of the original function. So how is that temperature change changing? And most of you got the units are degrees Fahrenheit over milliliters. It's always from the original function, the degree of the output variable over, the unit of the output variable, which is degrees Fahrenheit, over the unit of the input variable, which is milliliters. So this one, it felt like a lot of you got correct. Part C, very few people got correct, and this is where I want to focus right here. You were asked the meaning of f prime of 50 equals negative 0.02. What do you think most of you said? Most of you said that when 50 milliliters is given, the temperature change is goes down by 0.02. This is not correct. The temperature change is not represented by the derivative. The temperature change is represented by the original function. So this right here, the derivative, is representing the change in temperature change. So for example, instead of going up 0.75 degrees Fahrenheit, maybe you're just now going up 0.73 degrees Fahrenheit. So this would mean that you would expect the next milliliter of a dose to go, the temperature change is going to go down slightly. So the meaning is when a dose of 50 milliliters of a drug is administered, okay, everyone got that right, the temperature change is 0.75 degrees Fahrenheit, because I did ask you to include in your response the information given in A. That was part of the question. And so this is the new part to part C. And that temperature change is decreasing at a rate of negative 0.02 degrees Fahrenheit per milliliter. So if at 50 milliliters the temperature change was 0.75 degrees, at 51 we could expect that the temperature change would maybe be 0.73 degrees Fahrenheit. The temperature at 51 degrees is still rising for the patient, but the temperature change itself is going down. So really focus and make sure you're understanding this answer here.